Hi everybody, happy Saturday. I know you've missed seeing me. So I have been looking at some of your comments on the chapter 9 climate change videos, and it became really clear to me that there's some really big concepts that I think are getting lost. So I wanted to give you the advantage of me explaining some of the bigger concepts from chapter 9. So what I'm going to do is kind of an abbreviated version of the PowerPoint, go over some of those points. I'll probably do it in at least 2 videos, maybe 3, so you can tune me in and out. And I even wore my Dixie sweatshirt so we could be in the spirit, right? So let's take a look at chapter 9. Chapter 9 is talking about climate change and global warming. Those are 2 separate concepts. We can actually see the climate changing. Climate is long-term changes in temperature and precipitation. It's long-term range changes. And we can see this happening with glaciers retreating. We can see it with the ground melting. Permafrost is actually melting, and buildings that have been sitting on frozen ground are falling down. And in my hometown of Miami Beach, Florida, people regularly walk around with water in the street. At high tide especially. This is happening in multiple communities. It's happening in Norfolk, Virginia, which is one of the largest naval bases in the world. It's happening in Pensacola, Florida, which is one of the largest Air Force bases in the world. Sea is rising and people drive through the water to get to work. So we can see these changes happening during our lifetime. We can also take a look at the science, which is the record of temperatures from the 1850s all the way up through the 2020s, which we're in now. And we can see from the 1980s and on that we are seeing a warming trend where each decade is getting significantly warmer in terms of the average temperature per decade. So this is a measured record of temperature. We can also see things that have happened in the past. Human history has recorded changes in climate. We can see that in this picture there is a lake in Libya, and 5,000 to 10,000 years ago, the Sahara was actually green. It was like a savanna, a tropical savanna, like Lion King. And this water is coming from the ground that is stored in fossilized water under the Saharan desert. Obviously, it's no longer green, it's no longer a savanna, but it's a relic of what was once there 5,000 to 10,000 years ago. This is a civilization in Greenland. It was settled by Eric the Red, who was a Viking. And we have church records that show births and deaths and marriages that happened here for quite a long time. There were tens of thousands of people that lived here. And then when the North Atlantic became too cold and full of ice for them to go back and forth between Greenland and Norway, then the civilization died out and they also couldn't grow their crops. And that's what's happened if you ever visited Mesa Verde, which is an awesome place to go when we're no longer under shelter in place or settle at home. And this is a big civilization that was dependent on growing crops up in the upper areas here where they must have had enough water, large number of people. And why did they abandon it? It's because the climate changed. So Earth has been in existence for 4.5 billion years. We can see that there have been changes in climate on Earth since it existed as a molten ball in the sky, and then it consolidated through density stratification to give us the inner core and the outer core and the mantle and the crust, as we studied in chapter 3. Earth's climate has changed. Our atmosphere has changed. In the most recent future, in the most recent past, we know that there's certain things that cause natural changes in climate, which is long-term patterns of temperature and precipitation. So we can see these changes have happened. And what are these natural causes of climate change? And those go back to this slide right here, measuring global temperatures, what causes natural climate variation. And probably the number one thing is the input from the sun, right? Has the sun's output varied over time? Well, certainly it's changed in the time that the sun has been in existence, which is longer than the earth has been in existence. Yet if we look at past climate, it sometimes can be tied into sunspot cycles, not always. Yet if we look at the last 50 years, right, that the solar output has actually decreased over the past 50 years. So we're not getting more solar radiation. We're not getting more incoming radiation from the sun over the last 50 years. That is not what's causing us to have a warmer climate on Earth, warmer temperatures since 1980s. One of the biggest things that causes, in addition to the sun, is how the Earth's orbit changes. These two videos are really great to watch. I encourage you to watch both of them. And it has to do with these changes in Earth's orbit called the Milankovitch cycles. And what happens is the Earth will actually change its distance from the sun. It goes from a circular orbit to a more elliptical orbit, and it's exaggerated in the videos to show you how that happens. Why does the Earth's distance from the sun change? Why does our orbit change? It's actually because of the gravitational pull of Jupiter and Saturn, which is pretty crazy to think about. The other things that happen to the Earth's orbit is the tilt of the Earth can change from 24.5 to 22 degrees. We are now at 23.4 degrees in our tilt. And the tilt of the Earth changes due to also gravitational forces, but because we have a moon close by us, it tempers our tilt. In not swinging as wildly as like Mars swings much more in its tilt than we do. And the other thing that changes about Earth's orbit is when you spin a top, it starts to wobble, and the wobble of Earth also changes. So those three things about Earth's orbit are called the Milankovitch cycles, and we can tie them into variations in Earth's climate. And it changes how much incoming radiation we have and how it is affecting our seasons as well. We'll take a look at that more in a minute. The other thing that changes natural climate changes is if you have a variation of land and water, right? So land absorbs heat more easily. It heats up more easily than water. And also think about tectonic forces that move continents together and take them apart. So if you have a bigger land mass, that is going to change how we are absorbing or reflecting heat that comes into the Earth. So regional variations in annual temperatures vary based on how much land there is and the difference between land and water and how they absorb heat as well. We can have variations due to changes in ocean currents after global weather patterns, and that has to do with El Nino and La Nina shifting from warm water in the East Pacific to more warm water in the West Pacific, and that can change global temperatures for a couple of seasons. And the other big thing that happens is volcanic eruptions. We've had periods in Earth's history where there have been enough volcanic eruptions that have literally blocked out the sun and changed climate for a long period of time. There's a big deposition of volcanic ash in the Russian steppes, it's called, and they're hundreds of feet thick. So you can imagine how much volcanic activity had to occur for that to take place. So as we look at this, the Milankovitch cycles, again, which are fantastic to study more about, but you can see in this diagram that we can see blue is temperature and red is CO2 levels. And you can see that as temperature is low, we're in a glacial period, and CO2 concentrations are low. When we go up in temperature, then you're seeing an increase in CO2 as well, and we're in an interglacial period. So every time it drops, we're seeing a glacial, it goes up. We're seeing an interglacial period. And these can be tied into over the last 420,000 years. And now we've gone back actually 800,000 years looking at marine sediments and ice core data. This is science. These are data points that we're looking at, actual information that we get from sediments and ice cores, which you can read more about in your book. And we can see that these concentrations have changed over time, and they actually tie in pretty closely with the Milankovitch cycles. When you watch the second video on the Milankovitch cycles, I believe it's this one right here, where are we in the Milankovitch cycles? It will tell you, are we headed for another ice age or not? And you'll have to watch that to see the answer to that question. Okay, so we can see regional variations in land versus water. We can see that the troposphere, which is the part of the atmosphere we live in, and oceanic circulation, it will move warm water and warm air from the equator to the poles, and this air circulation intensifies the temperature change, and that's why we're actually seeing, this is 1961 to 65, and this is 2011 to 2015, and you can see the changes in average global temperature. You can also see the differences that are caused by the El Niño Southern Oscillation. That's what ENSO stands for, El Niño Southern Oscillation, and changes in ocean currents. This is when there's an El Niño happening, and there's a lot of warm water in the eastern Pacific, cooler water in the western Pacific, and this is a La Niña when you get cool water in the eastern Pacific, and it completely changes the global climate pattern. And you have rains and floods in this part of the world, and in Australia you're having a drought. So it can change that as well. And of course, volcanic eruptions, they can completely block out the sun. If you imagine this happening from many, many volcanoes at the same time, that you would have a complete change in global temperatures and climate. So those are the natural causes of climate change. Nothing that mankind can affect, and it's happened over millions of years, and we have specific data points that we can look at in marine sediments and ice cores that show us changes in CO2 and temperatures as well. So I'm going to go on to a second video to cover the rest.